Hello, good afternoon, sir. Sir, we will about to start our FTP in a short while. Can you please stop sharing your screen now? Thank you, sir. A very warm welcome to everyone. Good afternoon. Today we are about to start our third day of this FTP. Today we have with us Dr. Ashish Bera. He is an assistant professor in the Department of Computer Science and Technology, Computer Science and Information Systems at BITS Plani, Rajasthan. He earned his PhD in Computer Science and Engineering from Jadavpur University, Kolkata, and his MTech from Indian Institute of Engineering, Science and Technology, IIEST Shivpur, West Bengal. Dr. Bera's research interests encompass AI, computer vision, deep learning, human action recognition, image processing, and machine learning. He has contributed to top-tier scientific journals such as IEEE Transactions on Image Processing, IEEE Transaction on Systems, Man and Cybernetics Systems, IEEE Transactions on Instrumentation and Measurement, and conferences like AAAI, ESWA, and Nature Scientific Reports. He has also served as a postdoctoral research associate at the Intelligent Visual Computing Center, Department of Computer Science, Edge Hill University, UK. I welcome you, sir, in the third day of the FTP. Over to you, sir. Thank you. Sir, now I would like Sir, now I would like to request you to please start sharing your screen so that we can start the session. Thank you, sir. Sir, your audio is not audible.
Can you see my screen now?
Yes, sir, the screen is visible now.
Okay. Thank you for this opportunity to share few things about the agriculture and the applications of AI. So let's have a quick look into this small video and then I can start.
Sir, sorry to interrupt. We are not able to listen the audio and the video given. The audio is not hearable, sir.
Oh, sorry.
Sir, am I audible? Dr. Ashit, sir?
Yeah. Okay, understand.
Yes, sir. So your videos are visible, your screen is properly shared, but the audio is not hearable to us.
Yes, the video is intentionally kept mute so that it will not create too much noise.
Okay,
Okay.
sir. Okay, okay.
Okay. So
Okay, got your point, sir. Okay. Thank you, sir.
just so now can go to the next slide. I don't think the screen is properly shared here. I'm not able to
Okay,
go
sir.
to the slide. Is there any problem of present something else?
Sir, we are able to see your screen in which two videos are playing.
Yes, but after that I cannot change the next slide.
Okay. Sir, please try to press escape and then try to go to the next slide.
Then it will stop presenting. Stops. No, it's present.
So you have shared your entire window.
Yeah, now can you see the screen? Next
No,
slide.
sir. We are seeing black screen only.
Full
So
screen.
please press on share the entire screen. Then we will be able to see your slides. Yes, sir. Now it is visible. Yes, sir. Now your slide
Okay.
is visible, sir.
Okay, so now the content. So my topic is of this presentation will be the what are the next generation that AI can help our agriculture in Indian context. So the videos are still on. So the contents of my presentation are like how agricultural revolution has been taught. Before that, we know all these legends of AI. So John McCarthy introduced AI in 1956, and then the huge revolution came when the Lee Khan introduced the CNN architectures. And over the years, nowadays, we have different version of YOLO models which is basically for object detection. Till now we have version 11. So the classic computer vision techniques has been started since the inception of AlexNet, and now in 2021 we are working with various language models, VLM models, GPTs and all. So where we can integrate different visual models and language models together. So these are the one side of the development of AI and the new generation of ongoing generations of their development. On the other side, how these techniques can be leveraged into enhancing the agriculture across the globe through different research and deployment of different devices, systems, and others, so that the overall improvement can be achievable to meet the global food demands. Particularly in the context of India, we are also lagging, but we are not far behind. We have also started our evolution leveraging these deep learning techniques, computer vision, or language models based on different government schemes empowered by funded by different national and international agencies and various academic and research institutes, so that we can meet the food or supply of the agricultural products, as well as enhance the skill of the farmer, how we can improve the quality of the crop productions. So therefore we are very much interested to apply these new generation AI techniques to improve the overall productivity of agricultural crop yield productions, plant health monitoring, and others related stuffs. So as we might know about that, due to the climate change and global warming, a huge amount of crops generally wasted and suffered, so that farmers cannot leverage their maximum benefit to improve their quality of life. On the other side, India is a huge population country, and we are estimating about 1.64 billion population will come in near future. Then how we can fit the demand of the food as well as the health of the people with a cheaper food supply management. So there is a obviously utmost requirement of new technologies integrating like IoTs, AI, ML, deep learning, cloud computing, edge devices, remote sensing, and all. So all will be integrated together to maximize the crop productions. Now starting with the agricultural one, now we are basically dealing with agriculture 4, and somehow probably people also use this as a agriculture point 5, so that over the years, over the decades, how we are improving overall industrial applications as well as agricultural application. So this era will improve the health, hygiene, and food for all the people. Now, what are the different technology that we should use? So basically, as we know about the booming terms like artificial intelligence and AI/ML, so these are basically an umbrella term under which we have different and several issues that we can help out the farmers for growing their product, like precision farming and pest monitoring, crop yield productions, crop selections, their quality estimation through different AI/ML techniques. On the other hand, we can use the computer vision technique for fertilization, harvesting time, automated food quality, and sorting the crop, and all the things, as well as in terms of automation, we can apply robots, visual drones. In the video you might have seen, there are agri robots which can use to take the UAV samples from a large area from which manual inspection is really very challenging. So remote areas we need to apply through remote sensing images. Nowadays also satellite imaging are also helpful for weather forecasting, real-time crop monitoring and examinations of their growth, health, and finally the quality of the crop estimations. Through IoT sensors, we have lots of different types of sensing devices like soil sensor, moisture sensor, and nutrition management and chlorophyll meter, based on which we can diagnose the health of the overall plant in terms of their leaves or the content of their health in terms of nutrients and pathogens. So all of these are basically modern applications of modern devices leveraging the AI/ML. And most often nowadays people are working with the smartphones, so everything we can develop by doing some smart app for the farmers who can use a low price or a very cheaper smartphone, and through the cloud service they can get the information about how the weather, how the fertilizations, and how they can improve the stress management of the crop. So in India, in various rural area, these things are might not be possible where every time an expert will be available. Now, taking into these different challenging areas like pest monitoring, crop yield productions, plant health, and the plant disease detection. So we will take an example like how a computer vision technique or a deep learning technique can be used in detecting the diseases or the pests which are harmful for the crops. So we know this is an example of a banana tree where initial step is to collect the image from different plants and crops, and then those image and crops should be labeled. So in case of different machine learning technique, as you know, there are supervised technique, unsupervised technique, and reinforcement technique. So here if we apply some level of the crop, that which kind of crop and what are the content of that crop, that will give a level, and based on that level which we can use next for developing some experiment with that data. So before doing the experiment, we need to arrange or prepare the data by data cleaning, what we can call as a data cleaning. So removing the noise on what we can say noisy image and unlabeled data, or there might be some random images which might not be the of the same crop. So visual inspection and carefully uh, discussion with the agricultural expert, you can prepare your own data, and then you can divide the data into different splits, what we can take as a training split, validation split, and then testing split. So if general model, there are many different techniques. So some people use 70% train, 15% valid, and 15% test, where 60-40 is also welcome, 60-20-20. So based on different training testing ratio, you can do lots of experiment. And obviously, you have to apply some deep learning model here for the training purpose. And after getting the training model, you can evaluate different applications like what are the disease of that plant have. That is a classification problem. Or you can also get some score like regression analysis, that in which area of the plant leaf the disease might be detected using some bounding box or some score generated by the object detector. These can also be used to count the number of crops or fruits happened in that particular plant. So object detection is another area where we can apply this computer vision technique. Another is the classification. Third one will be the instant segmentation that will come next. On the other side here, if you look that how many leaves of the plant is everywise annotated with some bounding box, and the defective or where some disease has been infected that are marked with the red boxes. So not only getting the entire bounding box, it can also very specifically and very intelligently can diagonalize with different annotations so that people or farmer can focus where the problem is. So this is a very basic and overall pipeline. Now in case of object detection, so not only the object it will recognize, at the same time it will recognize or it will find out, detect the area of interest where this kind of error may arise or what are the different objects are present in that image. So you know the YOLO, you only look only once. So this is a very standard model, and year wise, day by day, lots of enhanced versions of this are generated. So people are directly applying this YOLO model on to develop the object detection, or they tune it by doing some minor changes to get these boundary or region proposals, and then that can be used to generate the bounding box. So you have also a scope to update or modify that underlying architecture. So these region proposals can then be generated in 1000 scale, and after the non-maxima suppression, it can generate only where the object belongs. So these are basically two stage or one stage proposal you can see. So on the other side, there is also some faster RCNN architecture and mask RCNN architecture. But what I can see, many people are nowadays are using this YOLO object detector for plant disease recognition in the field of agriculture. Whereas these are some other classical object detector which used in conventional machine learning approaches. Now another problem might be like the object detection. After that, we can use the semantic segmentation and instant segmentation. So segmenting means basically you have to sort out the particular region where the area or where the plant leaf can be located, and accordingly you can generate a mask to identify the area. So here if you see, if this is my input image, then generating that mask that will be added with to segment that image where the boundary of the leaves remains same but the background has been changed. So like various nowadays you can apply different tools to eliminate the noisy background or put in a different background. So for that, segmentation task is very much useful. So in this case, first of all, you have to localize, classify the image, then localize where the area, and then segment. So segmentation is basically making some cluster or grouping of the pixels localized in that image and generate a segmentation mask. So this is basically at the a job of at pixel level. So if you see particularly here on a from a research work where we can take an apple disease detection and generate different aspects where you can do as a classification problem whether the plant leaves are healthy or there is some disease like frog eye, and then you can apply some segmentations. There are multiple leaves, so you can count how many different leaves are there. So that is instance count, counting the number of instance or counting the number of leaves, and then object detection. So these are very much popular applications of deep learning aspect which can be used in agriculture as well. Now, if you have a object with multiple or very complex background, so there might be multiple objects. So each of the object can be segmented using different cluster of pixels and different segmentation mark. So if this is a human, so in that case, this is a mask with one. So similarly, other object can be detected with two, and finally the background is as a three. Now combining each mask into a single, then you will get the respective marks and apply different color to focus on particular object of that ellipse. Okay, so now in case of agriculture, what are the different sensors, devices, or cameras we can use? So if you see, there are different types of image capturing scenario. One,
আপনাকে লগইন পোর্টালটা দিয়ে দেবো,
আচ্ছা
মেল করে
আচ্ছা
যে ফর মেইনটেনেন্স বলে
please mute if someone is talking. Noise is coming.
রেজিস্টারের নামে করা আছে।
আচ্ছা
মাই কাউন্সিল আমাদের বহুদিন চেঞ্জ করা হয়নি, প্রেসিডেন্ট আর এগুলো করা আছে।
আচ্ছা
So if you look, so this is a image of a plant village data set.
আছে,
হ্যাঁ
সুতরাং এটা ঠিক আছে, অসুবিধা নেই।
মানে
Please mute who is talking.
কাউন্সিলটা পুরনো হয় না, এটাও কিছুটা করা যায়। এই সুদীপ চক্রবর্তী এখন নেই,
ও
বাদ যাবে।
আচ্ছা আচ্ছা
সৌনক চৌধুরী নেই।
আচ্ছা এগুলো ঠিক করার জন্য তো আমাকে তাহলে লিস্ট চাই,
হ্যাঁ,
মানে কে আছে না আছে, তাই না?
আমি আপনাকে নাম দিয়ে দেবো 5-7টা, কটা নাম লাগবে আপনি দেখে দিন, সেই
আচ্ছা
5-7টা নাম দিয়ে দেবো, সেই নাম বসিয়ে দেবেন।
আচ্ছা
আমাদের এসি লাস্ট নোটিফিকেশন।
So here you can see there is the background is uniform. Is same. So this data set is very much popular to the research community because it was one of the earliest data set and having around 40,000 images. But the background is uniform, therefore machine learning technique can easily detect, and people are getting around 99.95% up to of this data set. The drawback of this data set is that to detect a disease, you cannot take out the leaf from the plant and put into laboratory setup. So the challenge is you have to take the data sample or update continuously from the plant during its growth stage only. You need not to take out or make any damage to the plant. So therefore, this data set is not nowadays people are using. They are using more challenging and realistic data sets. So therefore, we need some real data. So what is real data? The real data might be you have the background and the context. So context is also important to get more clarity and more information which are helpful to diagnose the disease. At the same time, here you can see with the pond there is also some insects or pests. So several other data sets where people are working where the plants can be damaged or hinder their growth due to the infections of disease, insects and pests. So this is another data set which we can apply for agricultural monitoring. So these are basically normal RGB images with different background and different context. Some other are like the soil sensors and the leaf sensors. So soil sensors basically take the content of the soil like water, humidity, kind of nutrition from the plant so that the nutrition management of the plant can be appropriate during their growth period. Otherwise, they may suffer different diseases and their growth might not be optimal. This image you can see, this is a chlorophyll meter. This basically measures the content of chlorophyll of a particular area of a leaf. So we have seen for a healthy leaf, the chlorophyll content is much higher than the diseased leaf. So if we have a very healthy leaf, then we have higher chlorophyll content. So with this, you can also diagnose what is the lacking to monitor the health of the plants. The remaining two, these are basically thermal images which are taking using different C5 FLIR camera. So these also takes the thermal images from the camera, and this is an image of the rice plant. So where some defects might be there, based on that, if we can use this. So the benefit of this kind of FLIR camera having the temperature as well as the night vision capability. So during night, you can use this camera to get information from the agricultural field also. So to acquire the data, we need this kind of various kind of camera sensors, and in addition, we might have to integrate. So in that case, we need the IoT devices like Raspberry Pi, so that you can upload your data to the cloud and you can get the results to the cloud on an edge device. Now, the data sets. So in 2020 onwards, lots of huge data sets are being prepared by different scientists in Indian context also, in international context also. So what are the data sets category? One is like you can specify a particular crop or fruit and consider various diseases of that particular plant. This is one aspect. So if you have rice, you might have leaf blight, leaf blast, brown spot, so many other diseases which are very often happen in that rice disease. Similarly for tomato and grape. So these are crop specific data sets. Whereas in some other data set, they integrate all different types of fruits together and make a huge data set. So in that case, the challenge is very, very high, because you have intra-class variation as well as inter-class variation. That means once you take the grapes have different, so it is basically a comparison or discussions, or classification or recognitions of grapes related points. So there will be only 4 classes. But if you take all the different plants together, so this is inter-class, tomato versus rice or tomato versus paste, and then under tomato there are different inter-class. So for which a simple machine learning and technique might not give you the best performance. So that's why we need some advanced technique to develop the model. So all of these data sets are publicly available in Kaggle. You may download from Kaggle or Mendeley data, or in Elsevier journals. So they have also made these are public data. So if you are interested, you can prepare the data and start working on it. Now, from a perspective of how to write an article, once you have done some work. So what the people actually looking for in your overall research. So from the aspect, we have various models, like you have to develop some deep learning model to address a given problem, like we mentioned, like whether you are going for classification problem, object detection problem, instance segmentation, or object tracking. Then you have prepared the data. So different data and respectively splits you have generated: training split, validation, and test split. And then you can train the model. During the training in the model, you will get some performance which can be taken in terms of accuracy over the few number of epochs. So that is the performance metric used, and you can also plot the loss curve over the period. If you see here in this model, the difference between the training and validation is very high. So therefore, this model is not good enough to illustrate or to get the value. So basically, where if you look, the training accuracy is around 80% and your validation accuracy is only 20%. So therefore, your model is not good enough. You have to apply some other model. Now, if we think this model is fine, okay, after this you will get some classification result or predicted value in terms of confusion matrix, where you know true positive rate, false positive rate, accordingly it will give. So in your overall research, all the things should be given very precisely and concretely so that people can understand what is the thing. Now, the major challenge lies in our case will be like how we can generate a deep learning model to solve this problem, because we have public data set and we know how to plot the results, but how we can develop a model, that is the major concern here. Now, if you know, the deep learning is basically a convolution neural architecture, recurrent neural architecture, and more sophisticated like autoencoders. Uh, these are different types. So we will use here a simple deep learning like a CNN. So here, this is an example how a CNN can be built with. So we have basically a stacking of multiple layers where we can use a combinations of convolution layers with some activation functions like ReLU or p-ReLU, and lots of other activations are the sigma. So normally people use ReLU for convolutional layer application, but they can use some other one, that is depending on the application. So then for downsampling, we can use the pooling layer. So pooling layer is my like max pooling or mean pooling. And then these will be combined together. In addition, some people use batch normalization and dropout to address the overfitting problem. So a similar architecture is also shown here where the dimension of the image is also mentioned so that you can get a very clear idea how this architecture works. So initially you have a color image with 256 and 3 channels, then 16 filters with 3 into 3 kernel size, then max pooling. So max pooling is used to get the maximum for each of the feature space and downsample the image. So after this layer, your architecture will look like this. So after having multiple convolutional layer, it will be a deeper network starting with a input size of 256 into 3 to reduce the spatial dimension and increasing the channel dimension. So in deep learning, you know there are 2 dimensions. One we can call as a height into width, which is basically spatial dimension, and then the channel dimension. So as we move from input layer, so the spatial dimension of the input image will be reduced to a smaller size using that max pooling, whereas the filter size initially will be small and it will be increased. So at the end, you will have a thicker or a deeper network like this kind of feature vector. And then you can apply some flatten layer, dropout layer, and finally you can apply some softmax layer for the classification. So softmax will give you the probability of the predicted classes. Now, these are basically not standard backbone or architecture, because user can define this kind of CNN architecture by stacking multiple number of layers, and generally these are lightweight in nature, and this is not that much deeper that we expect in state-of-the-art backbones. Okay, so that's why this design can be considered as a lightweight as well as shallow design, and these are very tailored for addressing very specific applications. Like here we can apply for a crop disease. Now if I change this model to address some other problem, then the result might not be better, because these are very specific way to train this model from scratch. So that is the problem with this kind of custom or user defined one. So we can also apply some state-of-the-art model, which we called like ResNet 50, then DenseNet. So these are different backbone families, Inception, and then MobileNet. So MobileNet is known as a lightweight architecture, and all these models have a different architectural design based on which these models are developed. So these are state-of-the-art models and trained on the ImageNet 1000 class datasets. So therefore, they are much more generalized than this Halward or this kind of uh, user-defined backbone. But still, apart from this only ResNet or DenseNet or any state-of-the-art or applying some transfer learning technique, we cannot get the best result. So we need to include some more sophisticated techniques like attention or some other layer so that the representation will be improved a bit more towards learning the teacher representation to solve that problem. And have you heard about attention? What is attention? Have you heard about?
No.
So attention is kind of layer which is basically used in natural language processing. I will come to next about that. So it is a significant breakthrough appeared in by I think NIPS paper in 2027 by Vaswani. So this they are used to get define this architecture what we can call as a scaled dot product attention and multi-head attention. So basically what they are doing, so basically in case of a traditional feature map, we use the pooling and basically like a sliding window. So it only captures the context of very local region, very local area. But there might be some dependency which might be in a far distant apart, which cannot be captured using the traditional pooling technique. So therefore, if I use also some sort of LSTM or GET, so they can also easily forget this long range dependency because they are used for small scale dependency modeling. Now, attention is that which first introduced to develop this long range dependency even between the different feature space or local features which even far apart in the image plane. So based on that, the attention technique will focus. Now suppose you have a text, a word or a sentence like I am not feeling well. So once you apply some sort of attention, so the token, every token will be taken care of individually and find out which is the most relevant part of this sentence, and accordingly they will assign some weight, like the weight of like 0.2, 0.4, 0.5, 0.6. So it will basically focus the most important or most vital part of the information. So from that, attention can be used to denote in this image where is the most important area to focus. So like we use some glimpse that particularly this area might be challenging and have some issue. So we can very quickly focus and attend particularly that region instead of using some local window-based, sliding window-based technique to find out these things. So this is very interesting and a revolutionary applications of the NLP domain and computer vision. And it has some mathematical applications like how this is done. So it takes three vectors. One is called query, then key, and the value. So query is the user query. These three are basically built on the same feature vector. Okay, so query is that what is the extent where you can focus or emphasize. Key is the respective level. Then these are dot product multiplied. So it will get some information and the weight multiplied together, and it gives us the weighted vector. And then the value will be again multiplied to get the final attended region. So therefore, after passing this image, it will generate like a weighted mask like we have shown in the segmentation part here. So here, like not only this is uniform, it will only focus the huge region as per weight. So these are the main weighted area where the model will focus. So not the entire image. So particular area with that specific weight generated by that attention will be and that weighted is generated by the softmax operation. So all the weight will be in the range of 0 to 1. And using this scaled output attention, you can use also multi-head attention. So sometimes only a single head or a single controller is not sufficient. So in different application, like in transformer, we can use this multi-head attention where having the similar operational or functional capability, we have multiple similar attention head or attention agent. And every agent will do its operation and finally those will be integrated together. Now this basically used in case of transformer. Now suppose here we have only a single image. Now if the single image is divided into multiple parts or multiple tokens and every token is taken care of like this linear arrangement, like this token is representing here, this is here and so on. So now for every one you apply an attention. So now it will find out in which image part the attention has highest score or maximum we need to focus and ignore the remaining one. So therefore, it is very much useful for modeling in vision and NLP as well. And therefore, this is a building block of transformer architecture, or we can call as a vision transformer. So in computer vision, we have called VIT, which is again a huge breakthrough in vision research. And people have worked a lot using this attention mechanism and the vision transformer as a new generation computer vision technique. So therefore, this attention is a significant breakthrough aligned with our topic of this FDP. So here we can, up to this, what we have described. First of all, here up to this, we have described that we are going to develop a planned disease classification model. We can use state-of-the-art model like ResNet, TenseNet or MobileNet, or a custom CNN, what user can do, and then attention. So if we integrate all of these together, then I think we can have some powerful deep learning model. So do you agree with this? So up to this, these are the background of the applications of computer vision in agricultural field. So if you have any query, please ask, otherwise we will move to the next. Now we have worked some agricultural application called RAFANet. So basically the name came from a region attention RA network for food, item and agriculture. So taking all the words to make the RAFANet. So it is a generalized model where we can address different applications that I mentioned. One is plant disease, another one is food item, food dish recognition, and some insect pests. And these are evaluated on the state-of-the-art models and the data sets. Now, there are a trick. If you introduce a new data set, that means only a few work might have been done. So there is no challenge with that data set. to get better performance. So if you have a new data set and you report this is my accuracy, so people will accept it. But if you have taken a data set which is challenging and lots of work has been done over the years, people are slowly improving their performance like 91, 91.5 till 95. So lots of research will happen with this data set. So these data sets are benchmark data set and having a lot of research interest across the world. So therefore, this custom CNN or a Salwar design might not be good enough to get the better or improve the performance. So therefore, here we are using a standard backbone like ResNet, and as I have shown, we divide the image into different regions. So now, because in this previous diagram we have shown like we have an image, and then we can divide into different small region, and then find out which region is vital, which has more essential information. Okay, so this is this is under the pooling technique, region pooling. So each of the region of the food will be taken care of, and then we can apply some attention technique where we will call as a region attention, because we are attending every individual region, and then applying some feed forward network, which is also a crucial component in transformer. Like if you see here, not here, in next slide we have feed forward network. So two different feed forward network, which sometimes work like an MLP, multi-layer perceptron, and combine the attention score to refine the feature. I mean, which is more important region for classifying that image. Now, the problem is we have to diagnose the disease. Now, how we can develop this model and which are the different components that we should choose. So this is a very high level or abstract level architecture. Okay, so we have the input image. We have to divide the feature space into multiple small region, apply the attention, then refine it through different FFN, feed forward network, and finally attend or combine the attention score of the FFN and take the decision. Now, how we can design this feed forward network? So here we are using a one-dimensional or convolution, separable convolution. Have you heard about depth-wise separable convolution?
No, sir.
So may I know what are the audience people who are attending having prior knowledge about deep learning or anything? Then accordingly I will update or change the content so that you can get some benefit from it. So you are not too much. So here, if you can look, get your link. So now you have some understanding about algorithms. Do you have some understanding about algorithms? So now we are going to expand the diagram what we have shown in the previous. So here we have already mentioned the backbone in the diagram. So this is the backbone. Suppose we can take it from here, and that is the backbone part. And now we can upsample the features. So upsample is basically if you have a small dimension feature that will be scaled up. So basically if I use a ResNet 50 model, its output feature is 772048. Now basically it's a 7 into 7, I mean 49. So now here, how can we take only the 49th entry? We can take the region. So therefore, it's not possible. So at least we need to increase such that it can have some at least a pooling of 3 into 3 or 5 into 5 is possible, or even more. So that should be at least 3 into 3 square. So therefore, we have increased the feature space from 772, like say 40 into 40. So 6 times we have increased the dimension, the spatial dimension, but the channel dimension remains same. Now suppose now we have say 6 regions, and every region has a different feature space which we can stack together here. So now at the top, whichever is the region, that is top, and the last region is like that. So basically just you think an array, 2-dimensional array, you are stacking in a 1-dimensional stack. Accordingly you can arrange them the regions. Now once you have got the regions, so that is basically a pool. So now you can take every region have now 7 into 7 into 2048. So how we have converted this technique? So the CNN, base CNN gave us 7 into 7 into 2048 output feature. Then we have upscaling. So upscaling will give us 42 into 42 size, and from which we extracted different small region. Okay, though it is say 6 into 6 dimension, or if you use non-uniform scale, so this is uniform. So in case of non-uniform scale, or that means multi-scale, that means this pixel size might be different. Some will be say 6 into 6, some might be 8 into 8, some might be 14 into 14, or like that. So in case of transformer, it is like 16 into 16. So we have to unify them all again back to 7 into 2048. So from a single feature map to this upscaling and getting the different region, we have n number of region, okay, with the same feature size as the base map. Now with this, at the same time, what we are doing, we are applying some additional technique like the feed-forward network, where we can use or apply some spatial pooling, pyramid pooling, and convolution. So this convolution basically used to transform or the feature in a different manner. So separable convolution, you know, it works in a depth-wise and point-wise convolution. So it applies some lower rank factorizing. So the entire feature space is factorized into spatial dimension, apply the convolution, and then again it segregate the point-wise convolution, 1 into 1 convolution, and get the feature map again. So basically, though we share the same feature map for 2 paths, but the 2 different paths applies to different transformation technique on the same input, so that the attention can be different at different path. Okay, so if someone fails to capture the context, say, then the other path might capture. So ultimately, if we combine both of the attention score, then it will be a huge, or it will be a better representation than using a single path. And then we apply the layer norm. So layer norm is basically an alternative to the batch normalization. So batch normalization used in a batches to normalize, to shift the mean of in terms of the every mini batch, to normalize and reduce the overfitting regularization technique. So these are the basic one. Now here we can also take another kind of attention weight by using the sigmoid function. So initially we talked about the ReLU function, which is used in the convolutional layer, and for nonlinearity. Now we can here apply here sigmoid function like a binary 0 and 1. So which are very much prominent feature that will be compared as a 1, and which are very shallow, or I mean lighter, that can be considered as a 0. So basically it will create a weighted attention mask of the feature like we have done, shown in the previous segmentation, and then refine the feature, which is basically the addition of both weighted score through the attention layer. And then we can pass it through the next layer by a skip path. So to reduce the vanishing gradient problem, just time now back to that. And finally, it will be passing through a softmax layer. So this is the overall plan, overall architecture, and diagram of that proposed model. So how the entire model has been expanded. Now the challenging part is, you are good in computer programming or coding. Now how from that code you can develop an algorithm, so that once you write a paper and ask the reviewer to go through, the reviewer will very precisely will focus what the algorithm is actually talking about. So whatever the operations that we have applied so far can be integrated here in an algorithmic form. So this step 5 to 17, 16, we have talked about, like we have used a base CNN or deep network where we pass the input image. Now here one thing I have skipped, that is called as a data augmentation. Have you heard about data augmentation or image augmentation? It's a very common word and common technique in machine learning, where you can apply to generate more data sample from some limited sample data by introducing some more variations, applying some computer graphics related transformation like scaling, rotation, transform, then shear. All of these different types of operations you can apply, like augmentation, rotation, translation, scaling. But these deep learnings are also very smarter than these techniques. So even if we apply simple techniques like this, they can take it, because those what we can say, convolutions are basically transformation invariant. This is the challenge. So therefore, we can apply some more advanced or a different augmentation technique like erasing, GAN. GAN means we can apply the generated adversarial learning, or we can apply some sort of erasing, that means, or occlusion, that we can, occlusion means we can remove this part, okay, or make it a bit hazy, not very clear, so that let the model to learn what is the information is given there, or just directly remove some part. So basically In social media, we might have seen, and nowadays people are applying some sort of generative AI to get new images with changing the background, changing the dress, or some context, the objects which are in their hand, and so many things can be done. So these all are basically different applications of this deep learning or vision-based techniques to generate the Gen AI applications. So now after this baseline, we have done the upsampling this. So this is our backbone step one. Then we apply the upsampling. Then we take the regions. So all together, these three are basically taking as a step one or stage one. In the next stage, what we have done, so region pooling will give us the output like here with this dimensional feature space. Now we apply the layer norm, which is here with the attention. So this is the self attention that we mentioned, self attention, which is again a building block of there. And applying this, it will transform the. Now in the FFM part, so which is basically a simple MLP, where we apply 1D separable convolution on the average pool feature map. And on the other side, we are also using another pyramid pooling. So this is spatial pyramid pooling, SPP. So it pools the feature in terms of pyramid. So that means in pyramid architecture like this, so small window, then moderate window, and finally a bigger window. So like 3 into 3, 4 into 4, or 5 into 5, and 7 into 7. So if you have a feature space of like this, it can take the features from multiple scale. Like from this with 3 into 3, then it can take some other value from like this. So at a time, different area it can focus and take the good feature or the representational strong features. So these are two different techniques we can apply. And then here we have applied the addition. So we can take the addition of these two, average pooling 1 and 2 from both FFM. We can apply the layer norm. And then what we have missed, we have taken this path. So this path is basically a sigmoid function. So this is the sigmoid function, taking the attention weight score. So this is passing with this attention score and multiplied with dot product multiplied with the output of the FA. So FA is coming from the layer norm. So this is addition of the multiplication score with the attention weight. So one is this is the attention score, and this is the attention vector after layer norm. And finally here, if you add it, you will add one dropout layer to remove some random feature vector to reduce the overfitting. And finally, you can apply the sort max layer through the layer norm. So this is the entire model, which is represented as an algorithm. Now, if we have the algorithm, then you can very easily find out the code. So, because coding is a huge section, people might not be able to write the entire code in the paper. They will represent through this expression, algorithm, or equations, whatever you can feel convenient. So now come to the augmentation part. In the data augmentation part, what we have taken some random erasing technique. So we have randomly select a rectangle with randomly selecting height and width. Okay, so it can take a size of within 0.2 to 0.7 of the height and width. Take that area such that if I add that area, it should lie within this entire image. Otherwise, it will go outside, then it will be thrown an error. And randomly, we can replace that with some random value. So suppose if its initial value is gray, we can change into red. So the image will be changed from gray color to red color. So in this way, every time at every training phase, this operation will pick up random space and random color, so that every time the model will generate a new training sample, so that it can learn very precisely. So this term here, we are basically refining the feature at different forward FFM path, and to learn the context as well as learn the overall holistic feature. So this will enrich a more refined and weighted feature vector which is suitable for the classification. So up to this it is okay. Do you have any query? Now, if we, so it looks like it's very difficult at this moment. Now, how a simple model can be used for transfer learning for a beginner? How a beginner can start with? So basically, beginner can use a ResNet model, which is pre-trained, move the top layer. So this is a ResNet backbone layer. Then apply the global average pool layer, this part. So remove this attention part. You have input image, this backbone CNN, and then the gap layer. So this gap layer is basically gives us only the channel space. So channel will remain same, it reduces the spatial dimension. So it's a three-dimensional feature vector. For each of the spatial position, it takes only one. So there are 2048 channels. So for each position, it will take one. So ultimately, each of this entire feature or spatial space will be counted as a single one. So it basically then converted only the channel space. So these are the ultimate channels. And then you may apply a softmax layer for multi-class classification. So this is only a 4-line or 3-line code which you can use for a transfer line. And then you put the input and the output as a X. So this X is basically the will give you the class label or classification result once you train your model using the categorical cross entropy, and you can use any optimizer like Adam or SGD, any optimizer you can use. Loss functions, you know the cross entropy. And next is the learning rate. So these we call as a hyperparameter. So how the model will learn at which space. So this learning rate might be generally is empirically selected. So generally we can select as a 0.001 to start with, to get the SDD optimizer, to get the learning details, move from the total minima to find out the global gain, and slowly it will decay the learning rate. So what is the base performance? It will like that. And then you can also apply or add some additional constant like early stopping criteria. And if no further performance is improving, you can stop your training phase. So this is a very simple code for transfer learning. And you can develop in Python in TensorFlow. Now, if I come back to the previous this diagram, how the code we can generate. So again, we know this part as a the baseline transfer learning, like ResNet 1 to take the baseline. Channels are 2048. Okay, and we have 9 regions in the diagram. Here we for the regions 1, 2, 3, 4, 5, 6, 7, 8. So 9 regions for the understanding we can take. Now we apply this region pooling. So this is a function which is also a separate part where you can give the input how many regions you want to pull, then pass the image and the number of regions and then argument. Okay, so here that one we are resizing the image or upscaling from lower scale to higher scale. So resize function, then pull the attention. Then apply the sequential self attention with 32 units of attentional clock. And its activation is basically sigmoid activation. So while it will apply, it will be applied to all the regions that we have generated. Now we are applying, we have say 9 regions. So every region will be attended through the attention model. So self attention will figure out all the regions given. And then they will generate the attention score. So now out of this region which is important, have the highest score like say 0.5, 0.1 and 0.2 and 0.2. So it's given as a more weight where the model should focus. Then we can apply the pooling technique to reduce like global match pooling. The FFN block, so this block is that FFN block where we can apply some match pooling or mean pooling. So here we have applied gap. Gap is global average pool. And then the pyramid pooling. So 3 into 3 window it will select. So we have 9 regions, and then we can apply that one-dimensional separable convolution. This one. Then again apply average pooling. Where is another pyramid pooling? Because we are adding these features as a script path that you can add it here. And then I think this is not important. Okay. And then we can apply the sigmoid activation, this one. The sigmoid activation you can apply to get the multiplication and finally addition. And then we apply the dropout. So this is the simplified code. So few blocks are removed for easier understanding that how we have moved or we can move forward to generate the code, then diagram, and then algorithm and code to algorithm. And then these are the compilation part. Yes, any query? Any question? So this is the major part of the proposed methodology. So this is the FFN plus refinement. This is attention. This is the region. So now from this code we can go back. Region, click, then attention, then FFN, two different FFN that we have used, and multiplication by refinement. So in this way, we can move to generate the tag. So this is one work that we have done to address the once you will compile the model, you will get the model summary. So this part I have removed for making in a single page PPT. Like there is basically nothing hidden. only the ResNet has a huge number of layers. Those are removed. So input layer we have, then the first few layers of the ResNet 50, and here afterward from the self attention to the remaining part of the proposed network. And this is the final feature output. So here you can see layer norm, reshape, dropout. Okay, so that on the convolution that we have done. So this is the channel, and finally the feature is 7 and applying here at a softness. So now if you look, the simplified model has around 34.25 million parameters, which is quite huge. Now, if I use a custom CNN, that might not be more than 10 to 15 million. Therefore, these are not good enough to admit because there are 200 classes the items. That is not possible. And obviously, if I compare the result on the planned top dataset, which is a realistic planned dataset, this net has 85 around 84.9, almost equivalent performance. The exception does better due to the separable convolution and its architectural design, whereas conventional Newton transformer and other of works are not that much good, but this is again very competitive. Auto encoder. Another one dataset we have used has 102 classes. Here also we have also achieved a significant gain on the performance in terms of accuracy. Okay. Similarly, we have done also another work where the underlying the basic part, if you see, this part is remains same as the previous one. Region pooling, then pyramid pooling, and the getting those part. But instead of the 1D convolution, now we are using graph convolution. So you know the graph in case of computer science. So there are different nodes and they are connected through edges, and these graphs have the connectivity graph to the adjacency matrix, right? So now think of the regions that we have generated here are basically a node of the graph, every node 1, 2, 3. So now those regions are working as a graph node, and every node, you know, the feature is 2048. So to have n number of n number of nodes of the graph with 2048 features. So every node has now 2048 features. Using that adjacency matrix, they can define the information and interact the message passing to each other. Okay, so here we have changed the philosophy of the developing the model. Instead of using that traditional attention, we can also change into graph. So the graph is basically used in non-Euclidean text information, non-regular, but it can also nowadays use a lot of computer vision or image processing. So only that part we have updated, and this is also available in the library. So GCN implies the graph convolution, where output will be 1024 channel. So you are passing your input feature in say like 2048. This graph convolution will generate or reduce the feature of either any dimension, 1024 or 2048, whatever you want, you can maintain that. And it will again like a similar convolution with value activation and dropout rate of, and then you can apply the average score. Just remove that separable one and apply this graph. And here the input is D is the adjacency matrix, which basically meaning that how many nodes are connected to each other, like the adjacency matrix in a graph. Accordingly, they can interact. And then the average pooling, you can pull get the prediction. Fine. So this is another one. Now, just changing the separable layer by replacing graph layer is not enough option. You can play around by doing some additional layers here. One example we can give here. Here, our objective is to design a lightweight model. As you know, because we are now dealing with very specific images, so we can generate a convolutional stem or backbone like using separable convolution. What we mentioned, so custom CNN. But the most interesting part is here. So as we know, the ResNet or any backbone gives us 2048. So every node has 2048 feature. Now we can segregate those features into different pooling technique, combine those two, and finally we can split them every node with a reduced dimension. So basically what we are doing, so graph CG 2048, so global average pooling is 1 G 2048 and max pooling will be 1 into 2048. So if I concatenate these two, so we will have 2048 number of layers. Basically that is 4096. So this 4096 we have divided into 4 nodes with 1024 each. So splitted the node with lower number of features. Just every node is splitted into 2, and then again make a graph so that propagate the information and interact with each other. So this channel splitting will also reduce the feature space, so which will actually help to reduce the model parameter here. So if we reduce the feature space here 1024, there will be a significant drop in the model parameter. That is also useful to develop another kind of model. So now instead of that, you can apply any new logic, new idea you can add here and do your stuff. So this is called as a channel mixing and channel splitting and mixing together. First we mix the average pooling and max pooling and then splitting them into multiple. Now once you will train, you will get this kind of loss curve and accuracy curve, which you can give into your article to strengthen the claim that you have trained your model with that much of reports, and sometimes for high level work, these graphs might not be required. Some people ask, so reviewer asks, so we can do it. Now the results, if you look, obviously better. So this work is actually focused on the disease detection. So this is a general 27 class disease, whereas this is a nutrition deficiency. So like iron, calcium, magnesium deficiency of the banana plants will give different visual representation, and accordingly we can classify from what disease the plant is suffering from. So initially talked about plant health, their stress, nutrition deficiency. This is another one to demonstrate. Now how we will ensure that our model has really learned something good. So that's for that purpose we can use some visual explanation, which is we can nowadays called as an explainable AI, XAI. So which is basically like a GradCam image, line or SAT image. So if you see these spotted are identified, so if we map it here, so it is basically not exactly, it is called as a coarse grain. So coarse grain means it is a rough estimation of the region where something noticeable can be found. So here it can found here. So on the spotted area, the model has very effectively learned from. So this is the visual inspections. Now confusion matrix, you can know that is also important. The idea of this, like ratio of the positive negative to positive, false positive to negative. Accordingly, can get the accuracy, precision, recall, and F1 score. And this confusion matrix will give you every class-wise diagonal relation that what are the best error. Whereas these are correct, these are misclassification or wrong class. Now this is a result for ground leaf dataset where the health status of that dataset is important, like rust, nutrition deficiency, late leaf spot, healthy leaf, early last, and early leaf spot. So here if you see there are multiple different objectives or different what you can say applications we are focusing on. One aside whether we will check the health status, nutrition status, and the disease at which stage. So there are few data sets where they found the early stage disease detection, late stage disease detection, or mid stage. So early stage is much more important, particularly for health analysis in medical imaging also, like early stage cancer detection. So if you can do or detect the early, then you can get some solution. Na? Otherwise you will suffer. No solution can be made after. So here we can address also accordingly. Now to plot this confusion matrix, again you have some Python library like sklearn, where you can address the classification report, then confusion matrix, and also you can generate the heat map. So using those available library, you can get this confusion matrix or this grad cam figure also. Now another figure that I am going to show is called TSNE plot. That is also important, and reviewer also encourage this kind of plots to be given to understand the overall feature discriminability. Now if I use initial feature map like the base feature map here in this diagram, at the early stage we have seen so only this backbone. So this backbone is might give you around 50 to 70% accuracy. That means what? 52 again 30% is wrong classification. So if you look into this diagram here, you can see only this part is taken. So it is so performance average, but there is a huge pipeline to refine the further discriminability about the features. So what it does, so once you have the baseline, so this is the baseline, so all the different classes are mixed together, so it is not easily distinguishable. Therefore multiple classes overlap each other in terms of their feature representation. But once we apply those huge attention and regions all together, you see every class is now segregated from each other with a visual clarity. So that means now every class is easily distinguishable from another, though there are some loose cluster, but still those are well separated, not like this. So this will give a visual understanding or explanation that your model is working nicely. So these things are also useful to diagnose or explain your own model. So after this we have done so many things. Now what the further we can move in future. So we are almost at the end of the presentation. So as we are talking about the next generation, so next generation is always evolving. So initially I have shown that diagram where next generation actually represents the generative AI and explainability. So other than, if I come back to that slide again, might have forgotten about that. So up to this, what we have done AlexNet. Now here in between we have applied ResNet 50, DenseNet, then GPT. Now we are going to the VLM. VLM is Vision and Language Model, and which is the new era as a Gen AI or generative AI. So not only generate text, not only generate image. Nowadays, people are trending in social media by generating their own image with different description, and the model is doing nicely like Gemini, OpenAI, or GPT-4. They can give you some sort of additional information. Now, this is treated as a generative AI where we can use the LLM models and combining the vision part and language model, which is basically a foundation model we call as a CLIP, contrastive learning image. So it will take the image pair and text embedding and put the pairwise. So how these things are working? So the foundation model of this LM is vision language model. One is we can call it XD, contrastive learning. So it takes an embedded image like this, and here if you see that self attention, layer norms, addition, fast feed forward network, and so on that we have mentioned just before. This part is similar to already discussed. Now, in addition to this vision part, they are using some natural language token or text embeddings. Now, every token of language will be paired with so if you have image 1, so image 1 and this side text 1. So it generates an image with text pair. So image 2, text 2 pair. Okay. So in that way, for every pair-wise relation between the text and image, it will generate a similarity score, which can be a cosine similarity score. So this cosine similarity will accordingly it will classify the object image. So here we have a text encoder and image encoder both together. So image encoder can be like the vision transformer or any transformer or any CNN that we have discussed, and text encoder again you can take any sort of pre-trained LLM models that can one part or anything before. Now, if we have another work like this prompt engineering on the agricultural plant disease, so they have the image encoder part and the transformer part here. They use that image text contrastive learning and make some attention module, and then again refining with multiple attention block. Finally, they are explanation and the result. So the crop is suffering from dash tomato disease or something. So it not only gives the disease name, it will also give us a more textual information and generates that one. So the farmer needs this information to take further step how they can address or how they can solve the problem by applying some pesticides or applying some nutrition to the infected crops. So this is like a doctor which can be done in remotely where network or agricultural facility is not that much good. So for remote or rural area, this kind of thing will be very much useful in next generation. And poor country like ours will also enhance overall growth. So this is all about. Now we can conclude. So we can use some advanced deep learning model for cognitive decision making model and agricultural robotics. So we can generate the robots in our Indian context that we have shown at the beginning. Abroad, we use the agri robots to pick up the crops, strawberries, fruits for harvesting, as well as the food packaging. Everywhere it is automated, so that can be a challenge for us also in next years. And India should have also new data set can also be prepared from Indian context. So most of the data sets in agriculture are basically for other foreign universities, but in India we have also built a huge data set because this LLM are replanning a data hunting. So if you cannot provide much data, they cannot give a good prediction. Next will be this vision language model. VLM can be a good part to integrate both language explanation as well as visual description to enrich and the easier understandability for the learners or any human being to improve the quality. In addition, we can use the multimodal agricultural concepts, multimodal deep learning technique, where you can use image, then text, and then soil and other sensor weather information. You can take all these different sensor information and generate a multimodal deep learning architecture, which will also useful to enhance the performance as well as improving the overall agricultural growth. And then the interpretability, we can use the generative AI like the different model like this GradCam or explainable SAP line diagram, particularly focus on the infected part. So it will also give a clear idea that where the people should focus on. And finally, researchers and practitioners must explore model compression technique, lightweight architectures, edge computing, IoT devices, and so on for the real world deployment. These are few references of this discussion. Thank you. This is all about my presentation. Thank you for joining the session.
Thank you so much, sir, for this insightful and engaging session. Now I would like to ask the audience or the participants if they have any queries, you can ask it, sir. Sir, there is one query in the chat box messages of our GMeet today. So, Mr. Paul sir, he is asking if we merge all the models together, the computational overhead is very high.
Model or modality? Model means what you are talking. If we use multimodal, here the source of information is multiple, not the model. Clear? Like if I take only a simple resonant model, and there I can give information from image, information of text. So the input modality will be high, not the computation of the model itself. Model is basically that huge architecture that I talked about. So if we
okay, sir. Okay. Thank you, sir. Sir, the same question is asked by that person only. So there is total number of parameters of your model. He is asking the total number of parameters you have used in your model, sir.
That is 34 million. I have seen that. I don't know.
Okay, sir. Okay. Thank you so much, sir, for answering the queries. Now, I would like to ask if any other participants wants to ask their queries with sir. Sir is here with us. You can continue with your questions, please. Okay, sir. So I think there are no more queries with us here today. Thank you so much, sir, for this enriching and engaging session you have provided us today. Thank you, sir.
Okay, thank you all for joining. Shall I leave?
Thank you, sir. No, sir. Just wait a second.
Okay.
Yes, sir. So, as you can see on the screen, there is a certificate of keynote speaker that is presented by us to you, sir. This certificate is proudly presented to Dr. Ashish Bera in recognition of your outstanding contribution as a keynote speaker at FDP on recent research trends on NextGen AI, organized by the Department of CSE-AI and ML, Haldia Institute of Technology on September 18, 2025. Your expertise and dedication to the field have greatly enriched the experience for all the attendees and helped to make this event a success. Thank you so much, sir. Thank you. Please accept this token of appreciation from us to you, sir. Thank you, sir.
Thank you for the certificate, and it's privilege to me to give this opportunity from AI and CSE Department of Institute. I was also part of this institute long before, so still this
Yes,
connection
sir.
will reach again for the next generation AI development. That's good. Thank you for the initiative, and I also thank the organizing team who have organized this session. Overall, a big thank to all the participants for attending and session. Hope this might also give a slight idea about how we can move forward to do some small research. Because in case of deep learning, most of the institutions not only uh, reject skill, lots of institutions does not have that much of
Yes, sir. Sure, sir.
infrastructure to carry out the research, particularly deep learning. So they can use some offline or free online resource repositories that can also get the idea. And if there are some teachers are available, I'll also request or suggest them give the student a project like so that they can also improve their skills and get some new ideas so that they can get some job offer from other domains also. So this will also helpful for all the academicians involved in this domain or whatever you can say. Okay. So
Yes,
once
sir.
again, big thank to all of you, and I am concluding my session here.
Thank you so much, sir, for joining with us. Now, here we come to our end of day 3 of this FTP. I would like to thank you all for joining and staying here, making this FTP a successful one. Thank you to all the participants, to all the speakers. Now, as you can see in the chat box, we have provided a mail for the attendance link for today, and the feedback link is also there. So kindly fill this 2 forms within 5:30 p.m. as they will be not active after that. Thank you all. Thank you so much.